Welcome, part 28, 29. As always. I have no clue where we are in the series. It's also quite a long series for now, so I guess it doesn't really matter. Yeah, so today we work on Enderwire today because I am not quite ready yet with the other printer to continue there. I'm also not sure still yet how to call the other printer. So yeah, for now it's the other printer. Something's really weird with my audio. Okay, I hope it's only for me, not for you. Let me quickly try the other one. Hi there, Roberts. Let's give me 1 second. Hey there, Adam. So I think, yeah, it was just the earbud was doing like weird stuff. So I hope now it's okay. Yeah. So, for the other machine, I'm still working on the bat. Like, there's already something. Let me actually show you very briefly. So, there's now this like thing here in the middle here. So that's already there, and you can spin the motor and it goes up and down. So that's the status there. I only printed one side so far, the other side is missing, and like the entire bed mount is missing. But there's progress. And I think next week we can work on that and make the bed go up and down, at which point it's kind of almost a printer. So fingers crossed. Cool, yeah, but yeah, this week, switch wire. Just to kind of like bridge the time a bit. For the people who watched like the previous iterations of, or like the previous episodes of the stream, I should say, we had a lot of trouble with the BLTouch. So basically we changed the hotend and stuff, and what ended up happening, maybe if I just show it from the side quickly, what ended up happening was that the BLTouch here was like basically below the hotend. Like you already see, like from my finger, like there's not a lot of gap, and like we basically, to fix it, we cut the tip of the BLTouch there. Hi there, Steve. And I'm not quite sure if it's because we cut the tip or because if it's just because the BLTouch was already a bit funky before. But I have really problems getting like a nice first layer. Like if it's a small part in the center, no problem. But I'm currently printing a couple more of these boxes. And to print the box, it's basically you need the entire bed, like left to right. So the first layer is kind of important, and yeah, I'm unable to print those boxes at the moment because first layer, like here, it's completely like way too far off, and in the corners it's like way too low. And the BLTouch should fix this, but it just doesn't. So I'm a bit not concerned, but confused. So basically, because the BLTouch is too low and I got really bad results, I basically just made the decision to swap it out for one of those inductive probes, which hopefully should fix the issue. And it should be a relatively straightforward upgrade. So basically, we don't have to work on anything under the hood, because the probe will connect directly to the toolhead board. We have the canvas board in here, so that should be all the wiring is in here. We need to do some software tweaking, like configuration tweaking, but shouldn't be too major. Yeah, and to do so, basically, we need to swap out the main, or like the base part that connects to the linear rail. Which, yeah, will be a bit of like work to just like unbuild everything here. And then the probe basically just sits in the center here. Yeah, and then like while we are working on that, I'm a little bit unhappy with the homing at the moment. So at the moment we have sensorless homing in Y and in X, and it works. The problem is when the printer homes in X sensorless, because the motor is kind of like, we have like a core XZ system here, right? So the same two motors control the vertical Z movement and the horizontal X movement. What happens is that when the tool head like connects basically with the end stop piece here, the motors push further and like it kind of like pulls down the tool head. And I'm not quite sure. I don't think this has any impact on the precision later on. It's just like I don't like seeing it, to be honest. Because it's just like it moves in Z, and technically later on it should be fine because you home Z after X and Y. But still, like, yeah, I don't like it really. So what I want to do is like I have this like tiny Omron switch here, and it's not exactly the model that we would need. But this can go here on the side. So basically, the difference to the proper part is this one doesn't have the metal cover here. Like usually you have the switches with the, do I have one here? No, I don't have one. But yeah, you've seen it, like the one with the metal flappy thingy there, and then like it's just like it's easier to press, but that should be fine. And the other problem is that the holes here are 1 millimeter diameter, whereas should have been 2 millimeters. So I think what we will just do is we will just glue this with a bit of super glue here and just give it a shot. So we just glue it in. The small switch should be fine because there's like a really even surface on the back here. So this just basically connects here. So it should be fine. And I'll just want to give it a shot. I'm not quite sure. We can always like revert back to like sensorless homing. But yeah, while we are taking apart anyways, I figured I have the parts. Let's just try to do this. So basically this is how this would trigger later on. So my idea is basically it doesn't like forcefully move on the side here, causing this like weird ZX movement. So yeah, that's kind of like the idea. I hope this goes relatively quick, but then it's me and my streams, so nothing here is really quick and easy. So the plan is to do this quickly and then like just focus on like making the first layer nice and even. So it's kind of my goal is to have like basically 20 by 20 centimeter rectangle on this bed by the end of the stream with a pitch perfect, wonderful first layer. Cool, yeah. Enough talking. Let's just, I guess, take it apart first. And then we can rebuild the tool head mount. Is it showing a poor bed mesh? The bed mesh looks kind of okay. Wait, actually, let me quickly show you the homing and let me show you the bed mesh. Actually, I have tons of bed meshes here. My entire, took screenshots of bed meshes. My entire desktop is filled with bed meshes. I just tried to see how they will run. So here, basically, what's still happening, like the corners were not even. I fixed that. I leveled the bed. So the mesh itself looks okay, right? Like this is nothing it shouldn't be able to handle. Like yes, there's like a very steep decline, but this is definitely fixed now. And it still just gives me horrible results. I think it's actually a good idea just like to quickly do like a before and after. So let me just quickly show you like first the homing issue I'm talking about. So if I home this now, first Y homes, that's sensorless, no problem whatsoever, perfect. Oh, it's okay. That was the wrong side. Let me quick show you again. My bad. Let me quickly home X and Y again. And now you see when it connects. No, it's actually not. Well, now it's not doing it. Usually, basically, what happens, it just pushes this part down. Maybe it's like just like a force thing. I might have changed the parameters a bit, but yeah. So like, I would actually, if it now looks okay, let me do one more time. Yeah, it's still doing it. Like if you really look at this part, and basically this will just like move down. when it connects. Now it didn't do it again. Okay. Okay, sometimes it does it. Okay, never mind. We put in the switch. Problem will be gone. Yeah, it pushes down Z. So I think just like because the motor pulls and the movement in X is like blocked basically, right? Like it cannot go further in X. It just like pushes down because like the X and Z movement is linked. I don't think it does a lot, but yeah. So yeah, this is like the last bed mesh it did. Let me quickly do one run. And then we just take a screenshot of that, and then we can compare it with the after result. By the way, I have the window open because it's like super hot today. I'm not quite sure. I think the noise suppression should like filter out all the people outside. Yeah, looks like it works. So if it's noisy or distracting or something, just let me know, then I close the window. Yeah, and I also went up to like I had a 5x5 mesh the entire time, which I mean for small things works fine. I also use adaptive meshing. But now because I have so much trouble, I went up to a 7x7 mesh, hoping that solves the problem, but definitely, I mean, didn't do much. Didn't do much for me. Downside is it now takes forever to do the mesh. Maybe we can also tweak some parameters to make the meshing a bit faster later on. I mean, usually it's quite quick because you use an adaptive mesh, so if you don't print like the whole bed, it's just like a 3x3 mesh or something, so it's kind of fine. The weird thing is, by the way, also like what I tried is like, I thought like, yeah, maybe this bed is like not super flat, which I know it is not. I have a glass bed basically for the Ender 3, and I put the glass bed on because like then the glass usually is like way more flat when it's heated up than like the metal. And also with the glass bed, I had the same like first layer problems where it was just like not acceptable. So yeah, I'm not quite sure. Like, I think it's either the probe has a problem, or that's something motion related. But then it would be a bit weird because then like the back corner here is higher than the back corner here, so it's not really X. Just a bit weird. I was wondering, where did you find the Nomi Claw Self-Burner top piece model? I did find it on printables, pretty sure. Let me quickly check the mesh, and then we can quickly check. Yeah, so that's the mesh. So it looks kind of okay, to be honest. Like, yes, the back corner here is a bit high, but it's not horrible. Good evening, Neo. Yeah, so this is like, it looks fine. Again, like it's not perfect, but it is as flat as this bed will allow. And I assume, like, I would expect, because like really like this highest high here, right? This is one layer height basically, so it should be able to do it, right? This is 0, 0, or is it almost 0 somewhere here? Yeah, this is like totally doable. I would expect it to be able to lay like a perfect first layer with this mesh, and it is just not doing that. Let me quickly save it to config, then we can later just compare it. But yeah, then let's just start doing stuff. Printables. Let me quickly check. I'm fairly certain it's actually in the description. Let me quickly see. I'm fairly certain it's in the description. Printer parts. Stealth burner claw. Here it is. Yeah, it's in the description. This one. This is the one I printed. I will also just pop in a chat for you, Robert. Here you go. Finally catching another of your streams. Just got finished building the Voron 0.2 with the help of your videos. That's very cool. Just getting the best acceleration right now. Congratulations to your 0.2. It's a really nice machine. Like, it's by far my favorite printer. Like, I mean, I only have 2 at the moment, but it is a really nice machine. Okay, let's be nice and quickly shut it down, and then shut down, and then we can start taking it apart. 3, 2, 1. By the way, Neo, did you leave the comment today or yesterday with the PCB fan on the V0.2? Like, somebody asked about the PCB fan being constantly on. I didn't get around yet to checking if mine is on because I don't hear it. But I think it's not on. I mean, it's like, I just really can't hear it. Yeah, that's with you. Okay. Yeah. No, like, I don't know if it's on. Like, it might very well be. I know that for, I think even for Marlin, it might be. For Marlin, the PCB fan is linked to the stepper drivers being on. So when the stepper motors are engaged, then the PCB fan is on. But yeah, this was definitely Marlin. I'm not quite sure for Klipper. Like, really not sure. Most likely depends on the configuration. But yeah, I'll check that tomorrow most likely and get back to you. So, let's see. I think the next step would be just like to remove the bottom part here. Let's actually also open the side. This one, and then this should come right off exactly. And here on the back is one screw. Which holds this cable down, so we can unplug that. And I think the next one, oh, I have a random random screw sticking here. I think now we can just unscrew these, and then this should all come off. Oh yeah, these were like secured with nuts. I remember that. It is linked to the heater in Klipper and just never stops. I turned it down to 45%, but that was it. But you mean the small fan on the back, right? The one below the main board. That's what you mean. Just pushing out this screw from the back. The other one is not loose yet. Yeah, the small on the back. That's linked to the heater. That's odd. Oh, there's the BLTouch cable, of course. It doesn't want to go out. It's refusing to leave this printer. Ah, come on. Definitely not leaving without a fight. The pin here is already bent. I did not bend it just now, I think. Okay, if this annoys me for too long, I'll just cut it off. Here we go. Okay. Let's also fix the little pin here. There we go. Now it's straight. Cool. Okay, actually, no, let's just quickly give this a look, right? I can also just upload all the config I have at the moment. And then just copy my config if you want to, or parts of it. So the fan, this is the V0 by the way. Fan control, so yeah, this is what I have configured here. So it's 66% max power, kickstart time 0.5, heater bed. If it's now on all the time, I don't know, to be honest. That's something I would check, but I don't hear it or don't notice it running. So let me just... Wait, it's too long. Okay, I tried my best. It's too long for the chat. Let's see if we do it like this. Yeah, this is my config. It's only on once the heater bed is active. You got the values. Okay, yeah, but that's what I have. Not claiming this is perfect, but it works for me since a year. So maybe it's smarter to first remove the belts, because otherwise this might kind of like snap apart. I spent so much time getting the tension exactly equal on both sides. Okay. It's enough for now. It works for you, should be fine. Yeah, I assume so. I mean, I'm not living in a super hot climate, so maybe if you're like having like 30 degrees or more in your room, you need a bit more fan, but should be fine. I mean, also like all the components, right? Like it's not like they die if they overheat. They just like the pie will throttle down, the boards will crash. I haven't had this apart in a long time like this. Okay. Steve, I totally ignored your comment. Shouldn't need nuts on the back. You overdid it when you first put it in together because they're just in plastic. I'm not quite sure. You see here. Oh, it's a completely different part. Interesting. See, this one definitely has nuts. It has these like pockets for the nuts. Like the nut goes in here. That's definitely how it comes together. But this is like not the original part because of the BLTouch. So potentially this one just works a tiny bit different. This one here seems like it has heat-set inserts at the same spot, which definitely is a better solution. Yeah, this one just has heat-set inserts. Oh, I think these ones are in plastic. That's correct, yeah. These ones are in plastic, but I was like referring to the top ones here. I'm making an 3 switch wire, and I was wondering if I could get your clip config files. Yes, you can. I actually have them on GitHub. As always, I'm not claiming perfection. It works. Quickly look this up for you. Maybe it's also smart if I put this in the description, actually. That's not quite the latest, but it is somewhat latest. Here you go. Inserts, I love them. They up the quality of your prints so much. Using them whenever I need screws. Yeah, I think it's really just like making it nicer. Like, I mean, it also makes it more like reusable because the plastic will wear out. There's actually like super interesting video from Thomas Alandro, Made with Layers is the new channel name. He compared different inserts and different like ways of screwing into plastic. It's actually quite interesting because if you directly screw into plastic without any insert or something, it's not like a lot less strong, which I found quite surprising. Actually, I'll just leave that. We just need the screws. Oh yeah, that's I remember this. We didn't have enough of these. I repurposed these old ones. You saved me a lot of time. You're welcome. The off-tightening screw into plastic happens to me a lot often. Yeah, like that can happen for sure. Like it's much easier than when you screw into the heat-set inserts. And here we have the screw with oh, now it's gripping. Let me actually see if I have different screws for these. Yeah, so for example here, one example, right? The BLTouch here was directly screwed into plastic. And what happened actually, at some point there was like some pressure on the BLTouch, something happened. And these were, like the BLTouch was loose. So what I ended up doing actually is I added a little bit of glue to ensure that the probe is stable. Okay. To be honest, like I don't trust this BLTouch anymore. I'll just kick it out. Like this just goes. It served its purpose for the last, I don't know, like 4 or 5 years. It's okay. It can retire. Okay, all the nuts are out. Time to do some inserts. So just so we get this straight. Because now I have a lot of different screws. So 2 of them we don't need anymore because we're from the BLTouch. 2 go in the plastic here directly. The longer ones are here to tension the belt. Yeah, we'll figure it out. Worst case, you have to look at the manual. I'm just quickly getting the inserts out of the old part. Yeah, I already read the comment. Auto tightening is very easy in plastic, yeah. We have this very nice saying in German, nach fest kommt ab, after tight comes loose. Yeah, it's also like a thing in English. I heard it before, right? After tight comes loose. You just need to swap 2 of them for plastic ones. Yes. Let's just check step by step. I think like these 2 are the same, the one that go into plastic. These, yes, this should be shorter for sure. But shorter by good part. Yeah, I think these should be 8s. You're right. This most likely will end up being 8s. Okay. And 2 fresh ones. Okay, that makes 4, and I think that's... Oh, there are actually 2 more. We now have this like teeny tiny part here that goes on the back here to secure the probe. That also needs 2 inserts. Oop, hot. Hot. Okay, let's just connect the 2 half first together. I will use the black screws, although one of them had a little bit of issues right now with the head, like the 6 hex bolt was a bit rounded out. I think if we get it now tight, it's fine. Never has to come again, come apart again. One, two, three. I think that's it, right? Yeah. And then those 2 screws are to tighten the belt. It's also like, it always makes such a big difference for me. Like, these are relatively cheap Allen keys. And this is like a high quality bit. And like, often I have screws where this one just like doesn't grip it. But then like this bit does. Scanning. Yeah, you know that. Cool. 2 parts became 1. Then let's just put the probe in there. And to be honest, let's just cut the cable right away because we're not gonna need 2 meters of cable. It's actually a nice cable, so I'll use it for something else in the future, most likely. So let's see, what do we need here? Let me see what my magic screw pile has to offer. It looks... that's way too long. Actually, it's not... oh, that's actually the perfect length. So 25 centimeters. The only thing I'm concerned, I'm not quite sure if it's the right head, because this is now sticking out a bit. Just quickly... oh yeah, but nothing will collide with that. That's fine. There's like lots of space. So we can use this. We can use these screws. Let's see if I can get this together. Here we go. Perfect. I actually have no clue how far in or out this has to go. I think it would be smart to try this out before we put the entire tool head together. But I guess now it's like somewhat level, so this is basically the highest setting. Let's just put it down a bit. Now it's like, now it's pretty low. Let's just put it like somewhat halfway. Classical middle of the road solution. Now it's like, yeah, not quite halfway down. First results of the ring tower with only stepping up the acceleration and having the right input shaping, pressured ones and so on, from 1.5k to 7k, no ringing at all. Speed was 140, that's the same. Yeah, I run actually, like, I have 2 profiles on mine. One profile is like the prototyping profile, which I use to like prototype parts, and I use 10k acceleration there, and speeds go up to, I think for travel 300 or something. Mostly what limits you in the end is the flow rate of the hot end. So I have the Revo, and I have quite a lot of materials where the flow rate caps out at like 15 cubic millimeters. Yeah, 15 cubic millimeters per second, or centimeters. No, 15 cubic millimeter per second. And yeah, that just then basically limits your print speed. So what you really need to do is, like in your slicer and Orca or Pusher or whatever you need, set a max volumetric flow rate for your filaments. You can just try it out basically. At some point you will see like under extrusion, you know, like now it was too much. But yeah, that's really important to set. And then you can just set the speeds quite high. And then if you print the slow filament, everything will just like cap basically at that speed. But yeah, the V0 is an absolute monster. Cool, okay. Now the question is, do we yeah, we said we will add this, right? So basically this, I would just like glue it in place. I don't think if we glued it with super glue, like it won't go anywhere. My concern is a bit, if we glue it, like there's like a rounded corner here. So I cannot quite push it down. So it's like exceeding, it's like a little bit over the top. So what I would do is most likely, I'm gonna do it. Let's just take off like the roundness of the edge here. Now just a nice sharp corner. Let's actually do it a little bit more, but then this fits really neatly in the corner. Yeah, fits way better. And then basically what I would do, yeah, now we can basically just put like some super glue here. Then I can really just like push it down into the edge. I think I would just like let it like poke out like a tiny bit. That's like not like completely flush, just like maybe like a millimeter out. I don't want to sacrifice any movement in X because I really need everything I can get. But it definitely needs to be out a bit. Because looking, so if I just put this on the rail, so if I move this all the way over here, you see there's like a tiny gap. So this is how much we need to stick out. So it's like 2 millimeters needs to be out. Normal brass nozzles can print up to 17 volumetric for me. Failure happens when going above 18.5. I think it depends a bit on the filament and also on the temperature, right? So if you have like a nozzle, like if you print higher temperatures, it will fail earlier because it needs to pump more energy into the material. So if you print PLA or something, like you can get higher flow rates, unless I'm mistaken. That might be the case. But I think if you print ABS, and I'm mostly printing ABS, it will most likely fail a bit earlier. So Jake PLA and Polyterra PLA at 2020, yeah. Then I print this one I print at 255. What really makes a difference, like on this machine here, this is the so basically I swapped out I had like this old Ender hotend still, like not the original, but like upgraded it. But this is now the high flow, the 60 watt heater core and the high flow 0.6 millimeter. This makes a huge difference. Especially with the 0.6, like it's really easy to hit the max flow rate because like the nozzle is bigger, so you push out more material at the same speed. So for this machine, I wanted to have the high flow actually, because this machine will only print 0.6 for the most part. I see it over there. Give me 1 second to grab the IPA. It's pretty have a charger nozzle, but most of the time the nozzles manage more. Yeah, it's also, yeah, I don't know. Like, I mean, maybe I do something wrong, you know. That's just like my observation is it starts crapping out at a certain point. And I also don't like to go right at the edge. Like if I see issues at 16, then I will go down to like 13, for example. I just clean the part here a bit that the glue has like the best chances of succeeding. But yeah, I'll go down because like the thing is for me, I'd rather have a successful print than a fast failed print. Okay, let's just average super glue. I hate super glue. And I'm putting a healthy amount. And I'm also, okay, now the glue is on. Maybe it would have made sense to solder the wires before, but... Okay, let's see. I hear it click. And it's like pretty much the screw has like 0.5 millimeter of gap, so that's perfect. Okay, now let me fix my screw up. Now we have to solder. I don't know, like sometimes I just make really stupid things. Or do stupid things. Let's actually quickly figure out which of the 3 we need. That's definitely not the order of things I recommend, but hey. I assume. No? Yep. I'm struggling. Like none of the 3 connect for some reason. That's weird. Like none of the 3 2 outside. Yeah, Steve, that's also what I thought. The 2 outside ones. But I don't get what's going on with my cable here. 1 second. None of the 3 do give me continuity when the switch is pressed. So if I now connect the outer one with the outer one, there's no... Oh, you know what? This might only give like a very brief signal. Because sometimes I very briefly hear it. It sometimes gives a very, very brief beep. Okay, I'm not quite sure if this is a good switch for that. Let's see. We'll try it and then we see what happens. So the two outside ones indeed give a signal. Let's do the solder magic. It's slightly warm, but not hot. There's some really noisy stuff going on outside. I'm really sorry. I'm not sure if you can hear that. Let's actually use the same wire. I'm not quite sure where it's supposed to come out, the wire of the switch. Must be just on the side, I guess, because there will be like this section will be filled. Oh, you can pass it through here. You can pass it there to the front, and then you can go up the same way. Okay. Screw your hot into the mount mounting can just a probe. Yeah, let me first do the wires. Let's just grab the black one and the blue one. Here. Sometimes I'm really not quite sure why I like do stupid things like gluing the switch in before soldering the wires. I hope this is long enough. Yeah, it should be. Use the same acceleration value for everything, walls, infill, surface. I am using mostly the same. The only thing where I put it down is outer walls. Like for the outer walls, you want to have less acceleration. Just like for quality. But what I really like recommend you just make like one quality profile where you have accelerations and speeds down. Because like the quality will go down with higher speeds. Me making my life unnecessarily complicated. Let me take off these like ends here where they already like strip the isolation a bit. It's really difficult to push these through. No, I think we can just like put them behind the probe wire. And then the probe wire kind of like holds them in place. Okay, then let's do what Steve suggested. And put it back on. Oh, it's not. Just you, everyone does stuff like that. Yeah, I just feel like when I do it on stream, like I'm way more prone of doing stupid stuff like that. Let me quickly see. I think these are the screws I have in hand. With some of the more faster printers, now slowing them down does not improve print quality. That is true. I did see, I mean, like for the V0, I definitely just like really pushed it. And I did see like decrease in quality, especially when it comes to overhangs. I think it still, yeah, plays a role. But there's definitely like let's say lower limit where like it doesn't make any more sense. Especially when for V0, like it's a bit, yeah, you can go fast and it will look nice. Okay. It clicks. Let's see. So we need to put in not a question. These I think should be 12. A little bit more. Okay. Not a question, Steve. Do you know how low or high this should be? For me, this looks good. Like it's a fair bit higher up now. And I think the trigger distance is 4 millimeters, right? I've also found the server's stainless strip a lot sooner than black coated when screwing into plastics. Oh, really? That's interesting. You mean like the black coated piece, like the really black ones, or the just the darker ones? Just higher than nozzle because the probe can detect quite high. Yeah, I'm not quite sure. Like they're like different models with different trigger distances, and I'm really not sure what I have. I think I have 4, but like 4 millimeters trigger distance. But let me put it down like a little bit. So now it's still, now it's basically somewhere in the middle of the blue ring from the nozzle. I think that's quite good. It's quite like there's a secure distance to the print stuff. I think that's a good spot. Let's leave it like this and give it a shot. Some extra value to go with that looks really nice, between 1,500 to 13,000. 7,500 looks the best at every angle. Oxidize, here we go. Yeah, I used like I think 8,000 on my quality profile and like 10,000 on my speed one. Quick question, did you also look up a LiDAR sensor? What do you mean by LiDAR sensor? I'm not aware of LiDAR sensors in 3D printing. Wait, am I missing something? This should now. Oh, there's a random screw in here. I was like, why does this not fit into place? Oop. Wait. Maybe let's quickly put the belts in, actually. Then it's not sliding around like crazy anymore. Let me actually quickly take this off again, then it's easier with the belts. And then when the belts are attached, we can put it back on here. Beacon, yeah. It's an eddy current sensor, it's not a LiDAR sensor. Yes, I looked it up. There is the one problem I have with them at the moment. I don't want to run two wires here. So basically there's one that's the Cartographer 3D that has a CAN version, which I could buy. But I kind of would like to have from Big Tree Tech, there's the eddy sensor. And they have the eddy coil and the eddy USB at the moment. And I'm waiting for the eddy CAN because I want to have a CAN bus connection. But now that I like install this sensor here, I don't expect to upgrade like super soon. But yeah, it's pretty cool. Like, it's definitely a very good option. Not for the V0 though. For the V0, I don't think you need anything. The V0 is so small. I literally adjusted the bed like 2 times or something. For the most part, it just works. And I actually got really good first layers on the V0. Okay, maybe now it's time to put this back here. Let's also just like take it off on the corner, and then we have like more belts here. I think that's easier. just should make sure that like it's the same amount of teeth. And it's definitely not. Okay. This side looks good, and here is one teeth off. One tooth off. Okay, now it looks even. Let's put this on the carriage. With a lot of messy belts. Hasn't been tried, PTT Eddie. Klipper 3D Egypt, do you mean if I tried it? I didn't try it yet. I want to try it, but I do not have one. Mesh leveling or a Z value that I can save. Oh, I want something so that I can switch the sheets without adjusting the bed. That's a valid reason. I don't switch sheets very often. And if I switch sheets, like it's very quick to adjust the Z. Because just like you look at the first one, it's like, yeah, a little bit up, a little bit down. And then the second one usually is already on spot. The OSIC sheet and the Voron sheet have a different thickness. Yeah, that's also what I found. Like I have the golden LDO sheet and I have the OSIC sheet. And the OSIC sheet is a lot thinner. So if you switch between them, the offset definitely changes. Oh, these belts. Tightening that stuff, I don't like doing that. Yeah, it's always a bit messy. Sure, we get them in correct order. 1, 2. Now we can tighten the corner again. I mean, we could have also like released the tension on those. Oh, but it's definitely something changed. Ah, shit. These two are overcross. Yeah. Okay, let's see if we can fix this. Okay, yeah. Let's quickly loosen the corner again. And let me actually quickly take this completely off. We don't break anything. Hi, Paul. It's between textured and the non-textured. I switch between most often. And I just need the difference of 0.2, but by hand loosening or tightening the screws. Yeah, but you don't need to loosen or tighten the screws, right? Like, even without a probe, you can always just adjust the Z offset. You don't need to touch the screws. In fact, you should not touch the screws. Because then you will lose your bed level. Okay. I just realized that both sides are almost tightened to the limit. So we definitely have to like release the tension there, tighten that. So we just like move them pretty much to the bottom. And we also can loosen the screws on the side here. I feel like the belts on the switch wire are a bit messy to adjust. Okay, let's quickly do the corner again and pull like 1 or 2 teeth more on the belt. Hi there, Martin. Did stealth drop adjustment also fix the bad ADXL results where you're having on switchwire? I can tell you what the bad ADXL results were, Steve. Two things. Primarily one thing, which is a smart person, which I don't count myself in the group, would have not done the ADXL on this table. Because this table is anything but sturdy. Like, this is not a sturdy table. Don't do your resonance testing on a wonky table. So that was the main the main problem. As soon as I put the printer on the floor and did the ADXL, perfect. So that was like kind of one part of the story. Sorry, I'm losing my voice. So the table was one part. The other part, there was less showing up actually on the ADXL result. Okay, so I pulled now 2 teeth more. Let's see, let me sort that. The other part was that when I initially assembled this printer, I was running out of M3 T-nuts, which at the time wasn't a big deal, because like from my experience with the V0 build, I was like, yeah, you know, there are those like printed adapters to hold it in place, right? So let's just print some of these. And I printed these. And how they work is basically there's like a nut inside, like this. And then you put them in the extrusion and you tighten them. And the problem is you tighten them in this direction, basically. So this is how you tighten them. And the problem now is that they're basically hold like this by the V-slot extrusion, and you tighten the screw from the outside. And if you now look at this, basically what can happen, the entire tension is held by the plastic part, because the nut itself is not as wide as the V-slot extrusion. Like you can put the nut in here. The nut is not as wide. So only the plastic part later is what will connect. So if I quickly do this in here, so if I tighten this, only the plastic part will hold this in place. And I didn't realize that was the case. So this is not the best way to secure your x-axis. So basically what was happening, that this was held by 5 screws. 1, 2, 3, 4, 5, something like that. And these 3 were loose. Because basically what happened was that I tightened the screws, and the plastic part broke. So basically I just tightened the nut, the M3 nut, to the back of the rail. But like the rail was not connected to the extrusion. So this entire like rail was only held by 1, 2 screws on this side. So this side was completely unsupported. And like, funnily enough, like it printed kind of okay. I just had like really weird like layer artifacts on this half of the print bed. And I was like, everything is kind of like secure, like the nozzle doesn't wobble around, the tool head seems fine. It was only like when you pushed against the bar, you saw there was like very thin like gap. And when you pushed against the bar, you saw the gap close. But like everything kind of seemed secure, because also like this part here, right? Like it holds the rail in place in a certain sense. This one here, like not super secure, but it holds it. So nothing was obviously wrong. Seriously? Okay, I'm a little bit too distracted. The belts were not crossed here, they were correct, they were crossed here. So now they are crossed. Let's do this again. But the bigger it gets, easier plastic breaks, and if it runs, well, it turns for tightening. Yeah. It can work just now. Friction, not the best. Yeah, it's less the friction. It's just like you break the plastic part. You literally just break the plastic part. Okay, let me quickly make sure this is all in the right spot. Right, good. Also make sure to go through here. Something is overcross. I'm not quite sure yet what. Ah, it's overcross here on top. Let's see. So this belt is now on the rear one. Okay, this is now correct. Let's tighten this one first to the rear. How long can it take to like rebuild the machine? Okay, so this is on the rear. And then let's quickly push this through here. And you're on the front. Okay, I hold this here. And we can loosen the corner again. Okay, looks good. Off we go again. Okay, now everything is aligned. And I'll get the top corner back in. Okay, success. And the tension is equally bad on both sides. So that's okay. We can tension this now. Fix this. Like, I'm not securing it, I just don't want the motor to be like super wobbly. See, so here it's not on the roller. We want our belts to be on the rollers, please. Yeah, this one here is like way loose, way more loose. So I wonder if we should pull, like, try to pull one more. I feel like this belt is at least one teeth longer than the other one. Let me try to. Okay, I think I pushed in one more tooth. Yeah, now it's about the same loose. Okay, I'm just doing this like very, very like roughly now. That's okay. So basically it shows me just like we have enough like leverage room here to tension them properly later on. Cool, okay. Whew. That was no fun. It wasn't that bad last time I took this off. Okay, I mean the friction between the aluminum and the M3 nut. When they have direct contact, then you can also tension them, but only if they have enough friction. But it's too small. Yeah, but there's no friction at all between the nut and the aluminum, right? That's what I meant. Like the nut itself is smaller than the gap. There's no friction whatsoever. Like from the V0, the profiles have slimmer. Like the rail here is slimmer. This one. So on the V0 this works, but not with the V-slot extrusions, because the V-slot extrusions. Wait, where's the nut? Yeah, the problem is this is the nut. It can go directly in. There's no friction whatsoever. So with these, this doesn't work. For the V0, you cannot put it in like this, right? Because like the on the V0, the rail is like like this basically. So you cannot put the nut in from the top. You always have to preload the nuts. That's the difference between this rail and the V0 rail, which is obvious, but I just didn't realize it. And that's why you can use the printed parts on the V0, because on the V0 all they do is like hold the nut in place. And here now it accidentally became a structural part, and it's definitely not good enough to be a structural part. On your channel, how long is a piece of rope? Yeah, I know. I know, Steve, I'm sorry. Cool. This is okay. Let's put let's put the top part on. We don't need the front and we don't need the hot end. Oh, we do need the hot end because of the thermistor. Okay. Now the question is, did those screws change? And that's, Steve, what you mentioned in the beginning, right? Like these now changed. They are now much shorter. I'm not sure if they're 8. They might be 8. They are 8. Yeah, you're correct, Steve. They are 8. Let me see. Oh, but this 8 belongs here. I forgot one. A mechanism for the belt which you could screw and keep ejecting the end of the belt until it is tight. That would be nice. Oh, no, this is this one. Wrong screw. You mean like a ratchet mechanism where you can just like ratchet? I mean, it's kind of what you have with the tightening on the side, right? It's just like you have limited tightening distance there. But generally, if you don't release the belts here, you're fine. Like whenever I have to work on something, I usually just take off the corner. Same on the V0, you just take off the front parts. You just don't just leave it on here and you're like golden. And 3x8. Let me just take the black ones. I don't have the silver hardware here at the moment. Put this here. It's in here. Here we go. Okay, one side is in. Open the beer. Can I just explode it? Now everything on my mouse pad. Well, that sounds horrible. I just, everyone, since I'm curious, when and how did you all get into 3D printing? Well, I can tell you my story while I fiddle in this M3x8 here. So my story was basically I had no clue about 3D printing whatsoever. I kind of knew the concept existed, but that was pretty much it. And I'm a software engineer by trade. And at some point, I worked for a company where I did prototyping, basically. So we did like, yeah, clients came to us with like crazy ideas, and then we built like some prototype to show their idea in reality, and then they can like show it to some of their clients, see if the idea is good, if the clients like it or not. So a lot of prototyping. So in my team, basically, we had some software engineers, but we also had like some product designers and hardware engineers. And it also included 3D printers. Oh, that was the M3x8. There's another M3x8. Could have used the silver ones. Never mind. And then basically at some point during COVID, like we didn't have a lot of work, and I didn't really know what to do. And was technically slightly before COVID actually, but we didn't have a lot of work, didn't know what to do. And then one of the engineers just started showing me Fusion 360 and like designing parts and printing them on our printers. And that was actually my first interaction with 3D printing. And it was fun. I liked it. And then after some time, I left the company. But I really liked tinkering on stuff by then, and like printing things, designing parts in Fusion. And then I bought the Ender 3 for home. It was actually like quite a, yeah, not an easy decision, but I was like, oh yeah, but I will use it. Will I print? Is it worth the money? Is it not too loud? It's here in the living room. So I was really hesitant, and then yeah, at some point I just bought it. And yeah, then that happened. That's how I got into 3D printing. Me 6 months ago, a new hobby to try and enjoying. I am now wanting to get into CAN and be able to use them more than chopping other STL files. Yeah, I mean, if you just learn, if you learn cut, it really unlocks like a lot new capabilities. Okay, we quickly need to check out the wiring because now we need to like put 2 connectors on that. And then technically, like if these 2 wires are connected, we can already start doing things and see like if it works. So let's quickly open the documentation for the CAN toolhead port, which is the EVB2209. Importantly, we have the 2040 pinout. I was interested in it because of my colleagues at work 3 years ago. Got myself 2 Prushas and just deep dived into it. Yeah, that's it's a bit addictive sometimes. Okay, so we need the end stop switch. Which is this one here. So we just need the 5V and the GPIO 24. I mean, it doesn't really matter which one. It's just configuration. So basically, we just need to have like 3 pin of this JC here. And then have the 2 outer wires and the center one free, or yeah. Basically just 2 random ones, just not those 2 together. That would be bad. Then and then I think here this is this one. Oh yeah, this is then the next one here. So this is an inductive probe, inductive or fan. So it's the V in ground GPO6, and we need to set this. Is it a jumper? I think this is a jumper. Okay. That's one part. Let's quickly also look in the manual. Where's the manual? Build guide. And then English, not Chinese. Let me quickly download that. I feel like I have this file like 1,000,000 times on my machine now, but let's quickly see. Where do they talk about the probes? Yeah, this is the end stop switch here, so this is already one thing. So they have, let's just use the pinout they have here. So this is one. This is tap. I'm looking for inductive probe. I'm fairly certain they have it listed here. Here's inductive probe. So it's black, yellow, and brown. I think that's the same color that also we have. Just quickly. I said quickly. Come off. Thank you. Black, brown, and blue. this is exactly what they show here. So we need to create this connector. And then exactly, so this is what we said before. There's this jumper here that we need to set. That means I need to find, I totally forgot about that. We need to have that mini jumper thing. Yeah. Okay, let me quickly grab the box of the toolhead board because I have the connectors and jumpers in there. Give me 1 second. I have a little goodie box. Cool. So that's one part. And then the other part, it's all in here. I actually went on a little bit of like a mini AliExpress shopping spree, and I bought a lot of the. So these are the JCXH, the bigger ones. I still have to print the labels. These are JCX PH. So these are the small ones we need. And we also have tons of like the crimping. I still see like a couple in here. Let's use these. But we need the pins. So if I look at this correctly, both connectors are more towards the upper end. I don't think it's a bit addictive sometimes because yeah, okay, it's very addictive all the time. I still keep all my other hobbies, but my sleep time got deleted. No, it's not that bad for me. Okay, so we need to go up here, which I could show, but I also can just not show it. So it's this connector here and that connector there. So let's just do the end stop first. And I don't think we should like shorten these cables too much. So let me just like chop them down a bit. Actually, like we can shorten them a bit. Yeah, let's do it like this. So let's put the connector on here, and then we can put it in, and then like this pushes just over there. And for this one, we should remove the isolation basically all the way. Which I'm a bit afraid to do because it's really awkward to reach now. Maybe it would have been smart to do before. Okay. Let me quickly take off the top part again. That will make it so much easier. Two screws are not worth like breaking your arm. Measure twice, cut once, exactly. And in this case, lacking to come up with like a good description, but like don't cut too deep. Cut twice in this case, I guess. Okay, cable looks good. Okay. Now we can put this back on. No, it's much easier than like trying to like do this like with this on. I like bending the knot deep enough. I like the bending not deep enough in this case. Yeah, it's just like step by step. Like I'd rather do it like a couple of times than break the cable. Most of the time you get the mantle off. Yeah, it works most of the time. It's just like I don't want to I don't want to like damage the wire underneath. It's like much easier if you just have to take off the tip. Then you can just like, you know, like use something like this, which works quite well. But yeah. Yeah, like the tool would be this. But also with this, like sometimes, I mean, we can try it here, right? So if I would use the cable stripper. Yeah, see here, for example, it completely stripped the black one as well. And it's a setting. You can like adjust it, of course, to make it like better. We try again. Yeah, again, like it completely stripped the black one. So also with these, like it's not always perfect. Like another 1 centimeter off so it bends up easily and don't stop the door from closing. Do you think this will stop the door? Looks good to me. I mean, yes. Yeah, let's do it, Steve. Steve, you're right. 1 centimeter more would be better. It would have worked for the record. Or like it does work. But I think it's nicer if it's a bit deeper in. Today, like not today, but like this week, I was like looking into this type of probe a bit more, and I saw some references online to the same model of probe, but without the pre-installed wire. I didn't find it anywhere to buy, but this would have been quite cool. Like I would have preferred to not have a wire pre-installed there. I rather would have added my own. Okay. Now we just need to pay attention that we have the right 3 wires. Let me wrap this here. Okay. Maybe put this. This will be fun. To be honest, let's quickly figure out the length. But I think this wire should be like pretty much the same length. I think it's much easier to just leave this top part off altogether for now. Hi there, Jim. Since getting the Bamboo X1, I kind of miss tinkering on printers. Yeah, it's actually one of the, like, I was tempted to get a Bamboo at some point, but yeah, that was actually the main reason why I didn't want to have a Bamboo. Or a Prusa for that matter. I mean, it's nice to have a machine that just works, but I really enjoy the process of making it work. Quickly check. I'm not quite sure which crimp setting we need. Well, it seems quite good. Okay. That's a bad crimp. Okay, should be still good. Okay, so for this one, it doesn't really matter. Like, the polarity is not important. So we can just put one on each side. And if it wants to go in, we have a connector. Okay, that's number one. Then for this one, let me just leave it like a hair longer. Let's just do it like this. So it's just tiny bit longer. Most tinkering I've done with X1 is making Octoprint plugin for bamboo printers. Well, that counts as software tinkering. But how does it work? It works with the MQTT. I just know there is one, but I did not look into it yet. And installing X1 Plus. What's the status on X1 Plus? Is it still like developed, or is this already dead again? Because I remember I heard that Bamboo doesn't allow new printers to install it anymore. Yeah, this one was too far forward. It didn't grab enough of the isolation. This one is better. Okay. 3 pins we have. X1 Plus is out. There's a double stage download process. You have to sign a waiver with Bamboo to be able to downgrade to the right version that can be rooted. Okay, so you downgrade to the vulnerable version basically, and then you can still install it. Okay. That's a bit of a weird process, but I mean, at least they allow to do it, right? Okay, so I'm looking at the side thing. My connector looks different, which is funny, but I guess that's still okay. So blue is in the center, black on the left, and brown on the right. A bit hard to go into the housing. The blue one doesn't want to go in or out. I don't like that. That accent stuff you have put a wire to the 5-volt should be the middle bottom, not to outer. Yes, I now have to ground, that's correct. Oh, it's just configuration, right? It's just how you want to configure it later. But yes, we should follow what they do. So let me move that. If I manage to convince this wire here to go in. Which doesn't seem like it. Like this one just does not want to go in. The others didn't make any fuss. Now it's in. Okay. Let me double check, Steve. But I know you're right. I put it to the outer two. Which one was the BLTouch? X limit. Yes, they do it different. Let's do it the same as they do it. So the black needs to go one over. Oh shit, no, that was the wrong one. Okay, the blue needs to go one over. Okay, let's try this again. So we're looking at the locking mechanism. And then blue goes on the outer one. And black goes to the middle. But yeah, in the end effect, it doesn't matter too much. It's just like basically if you want to pull the end stop high or low. So you can just like change it in the config. And then you just have to invert it, I guess. Cool. Okay. We have cable. Oh, we also have to set the jumper. Let's not forget the jumper. Let's do jumper next. Okay, where is that jumper thingy? So for the inductive probe, where do we do that? We're on top, X limit switch, inductive. So we need NPN. What do I have? Okay, we need to check if I have an NPN or PNP. But let's first check this jumper here. Yeah, we will have to remove the board as well here. Otherwise, I cannot reach this jumper. Let me quickly clean up a little bit. Just like all the things we don't need anymore. So we need to remove this. Need my biggest mouse pad. That was gross. Using like daily for 2 years. That's why I don't have mouse pads. What did I miss? Not much. We crimped 2 connectors. Now we try to configure this. I think I have to really completely remove the board because like the jumper is directly under there. Wrangle this out. I feel like I also have to remove the spec part there, because this is locking the USB-C in place, which prevents me. Wait. Which prevents me from taking out the board. Okay. Carefully remove this, and now we have the board out. Maybe still stuck somewhere. Here we go. Okay, there's this jumper. That's like one thing I really hate about this board. Like everything is so fucking tiny. Okay, so we need to set a jumper on the inside position. Jumper set. And then the other jumper on top is the NPN, where the manual says NPN, shorted 2 pins at NPN. Okay, let me quickly check what I have. So this is a TL U5 MC2-Z. This is an NPN probe. NPN. So we need to set this jumper. And that was the one on top. Oh, fun. That's the one with the bent pin. I think I did quite a good job to straighten it out again. Yeah, okay. Jumper's on. We have one jumper here, one jumper there. It's also like while it's out, let's quickly just set the connect the connectors. The probe goes directly below. So the end stop first. End stop goes here. Probe goes there. And now we have to navigate it back in here. And then I have to kind of like fiddle the screws back into place. That went well. Okay, board is back in. Any reason you didn't do BD sensor? Is that what this guy is? Missed the beginning. What is a BD sensor? Jim, I'm not quite sure what a BD sensor is. This is a proximity sensor. Like a normal, old school, non-fancy one. Okay, quickly touching the arm again. Okay. That's back. Let me just quickly double check that I now have the right connectors. So for the proximity switch, we have the top one, where brown, blue, and black. I somewhere saw... wait, here it says brown is VCC, so this should be on top, which is on top. Blue is ground, which is in the middle, so that's correct. And black is output, which is on the bottom. Cool. Okay, so the pinout on this is correct. And then the X limit switch isn't quite shown as clearly, but it's the lower one of the two. So yeah, I think I have them plugged in correctly, so that's okay. Then let's add this back, because we need the temperature sensor. We need the temperature sensor to run everything. Let's quickly plug in the heater. Okay, heater's plugged in. And this one's always a bit of pain. Here we go. You see that exactly, there was a cable a little bit like squeezed in. Okay. Chat may not like things. Bad distance sensor. Let me open this. I've never seen that, Jim. I've never seen that. That looks pretty cool. No, this is not that, but it looks pretty dope. That's pretty cool. So basically just like it's real time. No, unfortunately that's not that. I was thinking about having an eddy sensor here, but also that didn't materialize because I was still waiting for the eddy can. See, just I'm really cautious with these. Because I did have my fair share of screw ups there. With accidentally like plugging this like in one off. Here we go. Oh. Yeah, this is not correct. That's not correct. Not in. So it seems like the bottom part of stealth burner is a bit too low, just a hair. Let's quickly check if we can fix this. Yeah, this is not quite in the groove. No, it is. Okay. Let's try this again. Yeah, no. No, it's... Now it's in, okay. Okay. Now it's in. Was a bit misaligned. Okay. All nice and secure. Let's quickly check the belt tension. Let's do a very rough first iteration. So we're aiming for 2.2. Let's actually do a little bit less. Let's do 2.1, which we actually now have. Let's do the other belt. Nope. A little tiny bit less, but it's already 2.1. That was pretty much spot on. Cool. Okay. Double check everything is in the groove where it should be. Didn't have any routing fuck ups. Looks good. Let's tighten the motors. As Steve told me, you have to tighten those. The manual says you have to tighten those, so I tighten. I am learning. And I think that we're ready for some magic smoke, right? I mean, almost. We still have to plug in and secure this one. See if I can. Are we ready? Let me actually also switch quickly my... If it wants to connect. So we prevent any battery run out situations. Okay, technically everything should work. As always, I'm concerned when turning on stuff like that, but also like I need to remember now. Every time when I turn on this machine, you have the click, 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 click from the BLTouch, which will now be missing. So I shouldn't be concerned if I don't hear that now. 3, 2, 1. Didn't hear any pop sounds, no smoke. Good sign. Okay. And switch clicks. Cool. Then let's go into the magic configuration fun. Magic configuration fun. So, let's do the end stop first. So for stepper X, we have the end stop pin here. Oh, do we have to? No, we don't have to unplug that, to be honest. So that at the moment there's a wire bridge, like a jumper wire, from the diag pin of the stepper to the end stop pin, but we can just ignore that. We can just ignore that, and instead this should be BTT for the tool head board, EBB, sorry, EBB. And then we need to quickly check the pin. Let's just go to their GitHub and check the firmware config. And somewhere there should be stepper. No, they didn't have the example here for the end stop, which is sad. Then we need to pin out, I guess, right? The pin out. End stop, it's GPIO 24. So this would be, how is the notation there? EBB GPIO 24. There might be like a pull down, pull up, something needed. We need to check it in a second, but this is some basic end stop pin. And then for the probe, we can actually check their config, right? Config. Probe. Yeah, so it's just this. Okay, interesting. So it's just this. So let me just take this and then let's save this file. I split out my config in like all different files. I'm not quite sure if I like it. I mean, it makes it much easier to find stuff. So the BLTouch and the probe section are very, very similar. So BLTouch is basically like a variation of probe. So the only thing that's different would be these. Like the pins, of course, are gone. But the speed, lift speed, and Y offset are the same. And this one's actually 20, I know. Okay, but this one needs to be different. So it's not EBB, but PC13 doesn't really make sense. I'm not quite sure if I have the right... No, this is the wrong one. This is for the older version. This one is the config we need. And here we have probe GPIO 16. Okay. GPIO 16. Save. Restart firmware. Then let's just check the... Oh, that is good. Z offset in section probe must be specified. Oh, I know why. I put GPIO 6. I put GPIO 6. Thanks, Neil. 16, right? Supposed to be. No, it's... Oh, I copied it. GPIO 6 is correct. I think I said 16, but it's GPIO... I copied it over. This is correct. 6 is correct, but thanks for paying attention. We need a Z offset. And I'll just eye that and say it's like... I don't know, 6. But I'm pretty sure the problem is that this section here... exactly here. There's this... so this would go here later on. So let's just set the probe here. Z offset should be fine. We need to figure out the value, and let's remove that from here. So basically, this one is manually set. But if you change it in the UI, basically, Klipper will update this config section here, and then it's set here. So basically, because this was BLTouch still, it said it didn't have a Z offset, but yeah, now it has. Let's try again. Need to name it probe. Yeah, exactly, Steve. Need to name it probe. That's what I did. Cool. Let's quickly just check the end stops. So at the moment, X is triggered, which means most likely we need to invert that. I'll push now the button. Yeah, it's still triggered. This is most likely the problem that I had in the beginning with the multimeter. I think either the switch is broken. No, you have hashed out BLTouch and gave it no name. No, I think it's correct. It's probe here on top. I'll just... Arguably, this is a bit chaotic what I did, but it's all correct. But I don't think our X end stop works. Like it's now it says constantly triggered, but if I press it and reload the state, it's still triggered. And that's in the beginning with the multimeter. Remember, I couldn't get like continuity, like only very weirdly, and I think that's the problem. Couldn't see top of my screen. Yeah, no worries, Steve. Like you are 99% correct or correct in 99% of cases. But I think then this is we cannot use this X and stop here. So I think it's just like the switch is faulty. I kind of feared that would be the case. That's okay. It's no biggie, right? We can just Let's just take this and just move it back here. So we use our like sensorless foaming. Let's do firmware restart, and then the X end stop should be open. Also some updates here. I'm always very doubtful if I should do updates. The probe is open. Let's do the following. I just moved the tool head down. And the probe is still open. Now the probe is triggered. It's not. Needs to go further down. So if you look here, like now it's like the nozzle is. This is where the nozzle is, and it's still open. If I put it here, now it's triggered. For my liking, that's a bit too close. So let's just move this down like a couple millimeters. Let's just move this down a couple millimeters. Let's quickly shut down. It's quick to do so. But then I think I was correct. It has a trigger distance of 4 millimeters. I'm a bit annoyed with the end stop switch. I get some. I get the exact same switch again. I ordered it for the slide swipe probe, which I will use on the other printer. Oh. Just take this. So just looking here now, it's like basically one Allen key with down. So let's just get this done quite a bit. Maybe like this, not like you can see anything. I think now it's like a fair bit down. Yeah. Now it's like 2-3 millimeters down. So looking at this now from the front. I'd rather put it actually a tiny bit more down. I think now it's, I mean, you have quite a good view actually from the camera. It's more or less like now 2/3 down of the blue sleeve. So I think that's actually quite a good height. Like there's then like still like 3-4 millimeters between it and the print. Which should be quite good. But then there's a bit more space between the nozzle and the bed, which I very much like. There's some stuff in the fan as well. This fan deserves some cleaning at some point. Let me do my cautious check if everything is aligned. Looks good. Oh, it's still again like out of the groove. Somehow this is a really tight fit. You really need to pay attention. This is like really sitting in there. Check everything is aligned. I mean, I really like this tool head in general because it's really easy to take apart and put together and like fix stuff. But like this connector here is really painful. Okay. Then technically we should be able to home. Let's just quickly double check that the distance is now okay. So if I now query the end stops. Yeah, now it's triggered. Now there's like, and technically could have like even moved it a bit more down. Like this now how much space there is, which is fine. Like should be okay. Cool. Let's try to home it, right? Magic, like it's really magic without a click. There's now a test for probe accuracy. Let's quickly do that. Klipper probe accuracy. Probe accuracy. Yeah, that was quite an obvious name. So just do a couple of samples. That speed is crazy. Yeah. I actually have the limit quite high for that. I mean, like the Z speed on this machine is the same as X. Can you have it? Yeah, I set the max velocity to 1,500 and the max acceleration on Z is 3,500. So if it pauses, it's like beep. Which is quite fun. There's also this cool macro where it just like moves in a circle. I don't have that, unfortunately. But now, like, you see on the webcam, I hoped this would be a bit better. See now on the webcam, like, or you don't see it. Let me put it big. Now I see this block here instead of the nozzle. So I really hoped, like, maybe this wasn't just the wrong probe to get. Maybe if I would have gotten a probe with a, because you get them with different, like, distances where it trigger. So this one seemingly is very short distance where it triggers. So maybe like a 10 millimeter one would be better, because then you can move it up and then you see the nozzle. But yeah, it's okay for now. So what is the accuracy? The accuracy is 0.005, which is much better than the BLTouch I think I had. So let's do... Actually, one thing I wanted for a long time, increase the lift speed a bit so it like goes faster off. Maybe also just do the speed. Let's do speed 8. Let's leave the speed at 8. Okay, let's do a mesh. Uh, 10 extra for move speed, 300, go for it. No, it's too much. 10k, I think 10k it could do. It's just like, yeah, I'm a bit concerned about skipping steps and shit like that. Let's calibrate. I mean, this is not super interesting, but could you change the camera angle? Not really. Like, you see the camera is back there. There's the camera. It's a bit limited from the angle perspective. I can't put it further down because it will collide with the print. So that's a bit how it is. But I really like having the camera back there because like you don't have any cameras in the front. Like if you look at printables where other people put cameras on this machine or like on Enders in general, they have as weird as arms coming up here, pointing down, and like, you know, it's clean. Like the camera there is just very clean. It's the same angle you also have on the V0 actually, if you put the camera on the back. It's always on the side with a 45-degree angle. Yeah, that's true. I mean, technically I can put it... I can put it in the center. I actually don't know why I don't have it in the center. I think before I didn't have it because of the belts and the cable chain. Here you go. No, it's in the center. Ooh! Ouch! That hurts. Okay, that's something we can fix. Wow, how did that happen? Crazy. Okay, but like the mesh looks like, besides that it's like kind of like in a 45-degree angle, it looks good. See, now the camera is in the center. At least, yeah. At least it's even. There's actually a really cool command on Klipper. I didn't know about that until like 2 weeks ago or something. There's this command called screws tilt calculate, but I always combine it with this. Screws tilt calculate. What it does, you have to tell it where the screws are. And now it just probes the 4 screws. So basically just like probed all 4 screws. And now in the interface, it shows you this dialog here, where it tells you exactly how you need to turn the screws. But before we do this, let's actually quickly heat the bed to 55 degrees, because the bed will always warp when it heats. So maybe this is why it's now super bad and usually it's good. Yes, it tells you exactly how many turns you need. I know it's missed the window, but it just tells you like you need to do 1 full turn and 20 seconds in this direction and in that direction, and it's like, it's perfect. This is absolute game changer. I didn't know this existed, but how you configure it, you just put this section in your config, screws, tilt, adjust. And then you just need to configure your 3 or 4 screws, and you just give it the coordinates. The coordinates it has to move to have the probe over that. And then you just give it the name, this rear left. I actually like this one. It will never, so basically it probes all 4 screws, but it will never tell you how to adjust the screw 1. It only adjusts, you only have to adjust 1, 2, 3. So I put my screw 1 in the back because this is the weirdest to adjust. And that's it. It just like it probes the 4, and then it tells you like this needs to go up, down, whatever, and then you can do it perfectly within like 2 attempts. I've been meaning to add screw position to bed level visualizer plugin. The current screw adjustment option doesn't make sense on the probe points the way it does now. I actually didn't know the bed level visualizer had that feature. I thought about that being cool, but it never looked into it. Until like 2 weeks ago, and now I figured out it can do that, and it's like, it's amazing. Like the amount of times, or like the amount of time this would have saved me. Yeah, let's wait another like 1 minute until the temperature kind of stabilizes. Luckily this bed heats really quick. Let's see. Yeah, should be fine. Let's give it a shot. Okay, yeah, now in the UI basically tells you the rear left. It never tells you to adjust. That's the screw 1. So the front left is perfect. And now you see the other 2 we need to do. It shows you here the direction you have to turn. And then the 1 minute and 9 seconds means basically 1 minute and 9 seconds, like just like the clock, basically. My screws are a bit weird. I have to do them from the top. So this one, front right. So it's like 1 full turn. And then 9 seconds is kind of like a guesstimate. And the rear one, it's basically the same. Okay, now we adjusted that. And then you just say retry. And it just does the 4 things again. I always just like add this command to move it up because I have to adjust from top. Yeah, now you see like we are way better already. So the front right and front left need to be like teeny tiny bit. I mean, for 1 second, that's always a question. Do you really want to adjust that? It's most likely already over. 2. And then the back one needs to be 11. And now we just do retry. Yeah, see now we're like 2, 1, 2, so it's like really close. Let's do one more round. So this needs to go to this direction. Way too much. Front right 1 and rear 2. Retry. This is I love this feature so much. Yeah, now it's fine. Like I wouldn't bother. Like you never get 0, 0, 0. So basically this one, it now tells us 1 second each corner. But this would mean basically that now it's quite good. So let's retry this one. And in the meantime, let me put some filament on. There's this like loose cable here, which we still have like one of those cable clips flying around. No, it doesn't seem like it. Too bad. Okay, now then it stays where it is. Now for a 7x7 mesh, it's actually quite fast. Look at this. Looks good. So what's the... So it's basically 150 microns from the lowest to the highest point, which is quite okay. I like this. Looks better than before. Cool. We still have to like do the Z offsets, which is now completely gone, of course. So let's do the good old paper. I totally forgot the command for that. Probe calibrate, I think. Well, first have to home anyways. Calibrate. Yes, probe calibrate. Almost proud that I remembered that. Well, now notice for the Z, it did like a fast one and a slow one. Didn't have that before. Okay, we are always an advanced level, of course. There's actually like a bit of filament on the nozzle, which is a bit annoying. So, see. Okay, now it's caught. So let's go up. Now it's kind of loose. Except we also need to make sure that our bed temperature doesn't drop too much. So now it's like more on the loose side, which I think should be kind of okay. I'd rather have it a bit too high than too low. Oh, I should have prepared Orca. I didn't prepare Orca. Give me 1 second. Orca. New project. And we are on the Enderwire, which still needs the... For the 0.2, I have the nice OSEC plate here. Still have to do it for the Enderwire. So let's just add primitive cube. Let's just scale that to, let's just do 60 by 60 and then 0.3 high. And if we slice that, we should get one layer, right? Yeah, it's one layer. And just a cube, and we can quickly use that to adjust the Z offset. Oh, it's the wrong filament now. Oops. Let's quickly wait for it to start, cancel, and do it again. You could also emergency stop, but let's see. 3, 2, 1. Takes its sweet time. Also, I feel like it was too low. So before we do this now, let's just add like a solid Z offset of like 450. Then this one in Orca, we change it to the right material. Nope, it doesn't. Can you let me slice this? Oh, this is interesting. I had it before. I have no clue. Like now if I click slice, it shows a dialog. And now it doesn't do it at all. Slice and it shows like this weird ass error dialog. I have no clue what this is supposed to be. No? Yeah, now it works again. Just needed a new project. Okay. Quickly put the dimensions again. So 60, 60, 0.3. We have the right material now. Slice, print, upload, and print. Yeah, now we'll quickly heat to 60. Printing eventually, I forgot how slowing the printer down makes the PLA seem shiny while the rest is matte finish. We'll have to make a profile for the outer wall speed like 50. There's a setting for that. I forgot it. There's a setting where you can like prevent the outer walls from having varying speeds, that the finish is always the same. But I cannot recall how it's called. But yeah, if you Google for that, I'll sure you find it. Fan screen for animation. Yeah, I like it. It's the Nomi, Big Tree Tech Nomi, but I still have the old one, which I don't mind. That's quite cool. Like I don't have any other screen. This is the only screen here. I know, but then the heat at the small parts will be a blob. Yeah, well, that's one death you have to die. Choose your poison, basically. It's a cooling section for filament and Orca size. Oh yeah, exactly. Yeah, there you can set that. Okay, let me also kind of like have the emergency stop button in reach. Too low. Now I have a scratch in my bed. I don't like that. I even added like already like half a... Second time this happens to me. I mean, they actually go out. The printer is really tough in handling that, taking that. But why? Let's do another probe calibrate. We had the same last time we did this. So now it's really off. Okay, it's like way high now. Let's quickly save config and just try it again. Okay, let's print this again. Yeah, the eyes look quite cool. Like it just has like I think like 6 or 7 different animations. Yeah, this one is the waiting one, which shouldn't show now, I guess, because it's technically printing. Now this is heating. There's like this heating bad. There's one like heating bad, heating probe. The heating the hot end, probing. Then there's print starting, print done, idle. Yeah, there are a couple. You don't have an additional offset in your slicer, do you? I shouldn't have, I think. I mean, I didn't have before. Is it something you can set in the slicer? Let's see, but now we just walk our way down. But we had the same thing last time where like the paper was like friction, but like very light friction, but then like it was way too low on the bed. I mean, yeah, this is really not a big deal. Like this goes out, and this is like quite an old thing by now. The other side is fresh and shiny. What side did you put the X at stop, and what side does it home? The X end stop doesn't work, right? Like it doesn't trigger. But the end stop is on this side. At the moment it homes this direction, but with sensor is homing. Oh wow, this is a massive blob. Okay. Now we need to kind of like inch down. Already overshot a bit. This is really messy. It's just like get a rough idea. Let's quickly pause to relieve, like if you change it too much, like there's still like pressure in the nozzle. So if I change it a lot, I always pause for a second. Just that the nozzle pressure kind of can reset, basically. You really see like where I paused before and after it was like completely different already. But still needs to go way up. Slowly getting there. I think this looks quite good already. Tiny bit more up. Yeah, I think this looks good. I mean, you don't see anything, but... This looks quite usable to me. Let's just do this entire thing again. Clip off maybe a G-code in the start setting. What do you mean with a clip off that screen? Yeah, I mean, like, this was the end where we did it. This looks quite okay. Maybe still like a bit up. So I'll just print the same thing again. I'll just move it like another 0.35 up. Try full bed test. I will most definitely, Steve. I will most definitely. This is the goal. Like, I want a full bed. Nice. Because this I also managed with the BLTouch. But I feel like the probing is a bit quicker. I mean, technically it's the same speed. But I think like it waited for the probe to deploy sometimes a bit more. I don't know. Oh yeah, and this is the probing animation. Which is a bit oh, now it's fun. It's just like two circles like doing this motion, which is a bit boring. There's also like different software where you can put on this display. And then some people have the meow burner with the kitty ears, which I think is a really cool cool addition to that screen. I actually want to do it as well. Might be a tad high now. Let's see. That looks actually quite good. Kind of like sneak peek in here. Okay, you don't really see anything. But yeah, it looks quite usable. I've heard of people adding a different offset based on the filament material. They added to the filament settings G-code scripts. Oh no, you mean the first layer flow? Because I heard of people adjusting the first layer flow. But I don't think you can set the set a Z offset. I think it's here in settings overrides. No, I don't see it. But yeah, the setting exists. I know what you mean. That's definitely on cooling. Like you have the flow ratio that you can adjust. Yeah, there's also for sure this M851. I don't even know what M851 does in Marlin. What is M851? XYZ probe offset. It does. It's just it works a bit different. This is basically what you dial in here with the Z offset. Oh, now it's too far off. Now we have A little bit of gaps. As I mentioned in the beginning, like looks like a little bit off, or too far up. So I would say let's go down maybe 25 and just try this again. I assume like we will need to do this like 2 times more maybe. Yeah, I mean it's not horrible on one side, but it's still like barely closing the gap. Like it's really easy to like pull. And then here, just like it kind of like was tiny bit too less. So Jim, how this works in Klipper is you have in the config, you specify the Z offset basically. You specify the Z offset here, and that's the Z offset. X and Y, I think, can also be set somewhere, but yeah, this is basically the offset. And then this is the baseline, and then during you can still adjust up or down with this Z offset. And if you click on save, it will apply that value to your config value basically, and this will become 0 again. I feel like it's very complicated system, to be honest. I'm not a huge fan. So basically, if you save, it will apply this, what I now have minus 0.445 to that minus 2.5 that's in config, and then you have to save config to write that to the save config is basically the M500. Yeah, now it looks a little bit better, a little bit more squish in the line. I feel like you can, like on the first line, you can already tell quite well. Okay, let me go up 0.005. Okay, I think now it's looks pretty good. Then Steve, get ready for your full bed mesh, our full bed. Let's see. So let's do this with 200 by 200. Center that. Let's try that. It's not full, but close enough. Actually, let's do... I don't think it makes a huge difference. I think 215 is the max I can do. So 210 by 210. No, I see gaps again. So we're still a little bit too far off. Then let's just move down another 0.015. Okay, but it looks basically we're there. There's just like teeny tiny gaps here. So I think it's fine. Like I went now down a little bit more. Let's just give it a shot with the big one. Okay. This again gives me this error message, and now it's broken. Now I cannot print anymore. Now I need to go back, new project, no, add primitive cube. Now I have to do this again. I have to sometimes, I'm really annoying. Oh, I actually now did it before I pressed print. What? Okay, it's printing it, so I'm not... Is it now the right one, though? It is. It's a pretty big rectangle. Okay, cool. Let's see how it goes. Curious. But it's not super interactive now. Wanted to grab the bit of filament on the nozzle. At some point it just has to work. Yeah, I'm pretty sure it works. So if we still get like now the inconsistent Z, then at least we know it was not the BLTouch. And then we need to look for the next culprit. But I'm pretty sure like if it's now still... If it now still has the issue, it must be mechanical issue with the motion system. Oh, by the way, we also or I can do it later, but we should do the resonance shaper calibrate again because we messed around with the belts, of course, but not super important right now. I mean, this machine by now has a resonance tester on Y and a resonance tester on the tool head, so you don't have to plug anything in. It's just like resonance shaper calibrate and it just does it, which is really nice. Saves a lot of like, I mean, not a lot of work, but it's like, it's nice. Never had a problem, but using Windows and I always close the slice and reopen when I want to slice another file. Don't know why I do that. No, like technically Orca is always running more or less. I just have it open in the background. But it's also like, I feel like the problem is always when I use the primitive cube thingy. I have this bit of feeling, like I don't pay enough attention to it. Like it's not super often. Like now it's extreme that we had like 2 times in a row. Like some have it, but not really like, not really bothered by it. Let's see. Yeah, but it. Hope it just now works without any problem. Off we go. Actually, quickly remove the prime line here. Oh yeah, this is literally the limit. I heard the click of the end stop switch. This is as big as it goes. You actually see it here, like the impact of the switch. But it's just the perch line, so it doesn't matter. Not the perch line, the skirt. I'm really curious. I mean, so far it looks good. Before I had even issues with the corners not sticking. So hey. Off we go. Looks like in the corner it's a bit too low. Just have to quickly wait. If I show it from here, you don't really see a lot because of the light. Oh no. I see bad things. Here it's way too close, there it's way too high. I mean, this could just be like the corner flow, but you see like all the gaps here, like all the black. All the gaps. I wonder if I should adjust a bit down. Yeah, let me just adjust like minus 25 down. Because at least so far it's consistently too high, so that's, I guess, a good thing. And I didn't tune the small corner flow compensation yet. And let me actually just, because like this is not super important, let me just speed up to 150%. Nope, but I think this is too fast. I think we might get a little bit like of under extrusion now, and I'm not quite sure if it's now because of the speed, which shouldn't, but let's keep it consistent for now. Let me just try to give you the, I think from the top it's the best. Oh, sorry, that was the wrong button. This was the button I wanted. Oh, wrong button again. Sorry. Oh. I wanted to zoom out. It kind of looks okay. Like it's not like, yes, there are some gaps. It could just be bad Z offset, but it's not in the ultra extreme difference that I had before. Like basically I had it like not sticking in on one side and being like completely squashed on the other side. So this looks way better than before. Let's wait for the corner area here, like this area here. I adjusted it down around here, right? This is where I went down, and then like we went fast and we got like a little bit of gaps again. But now here it looks actually pretty good. Like in this area it looks now really good. Yeah, so basically in this like stretch like when it now is in the center of the movement, we have around 16 cubic millimeters of flow. So it's relatively high already because of the large nozzle. Neo, that's what we discussed before, right? So basically, in the middle of the stretch now, it's 16 cubic millimeters of flow. And I wonder whether like the issue we had here with the under extrusion after accelerated is just like because we reached the flow limit of the hot end, which we shouldn't because it's a Revo high flow with the high flow nozzle and the heater. But might also that the filament just needs a bit more temperature than to flow properly. Well, this looks pretty good. Like, I mean, this area, yes, okay. I mean, even this, if this would be a real print, I mean, it's not perfect, but this is like a workable first layer, even with this. This is a bit more center for you. Looks pretty good. I guess, like, I mean, if I would now start again, if we do it the second time and we still have these issues here, then I guess we still have to move down just a tad. And then what I definitely have to do is the small area flow compensation. That's something just I have to tune. I feel like with the bigger nozzles, like the small area flow compensation is just really, really, really important because like it's so easy to get like over extrusions in the small corners. That's what I talked about in the beginning. What do you mean, Neo? You mean, oh, the flow rate? Yeah, exactly. But yeah, this is now basically, this is PLA. And you see, like, if we can maybe like, no, I want to focus now on the first layer being okay. But I would expect this hot end to crap out around 20 maybe. So if we, oh, but actually like, so if we now are at 15, right? That's what we said, or 16, we're now 16. So if you're now at 16 and then basically I increase the speed by 50%, which means then basically we were at 24 cubic millimeters, right? So basically 24, it's kind of realistic to get under extrusion. That's the thing with the big nozzles. They push so much filament that if you then go fast and push a lot of filament, like it's really easy to get under extrusion. This looks good. This looks really good. I mean, if you ignore this again, this looks like a really nice first layer. My chat not being seen. Steve, now I see your chat. The last message I saw before that was try a full bed test. Do you remember the same issue with your Voron and you worked on tool without it getting better? Yeah, you mean on this machine? Yeah, this tool head was cursed. I mean, I now had so many weird ass issues with this machine. And pretty much all the issues I had came down to the old parts from the Ender I still used. It was like, I kind of have it like here now at the moment, but this hot end, that caused like all the stringing issues and the inconsistent extrusion. There was just a hot end. I don't ask you what it is, but it is this hot end. The first layer, horrible. We swapped out the BLTouch for a new probe. Perfect. So yeah, all the issues I had are the old parts. And the printed nuts for the X extrusion cost me a bit of trouble. Before the AXL take that nut from the X carriage. Thank you, Steve. I kind of forgot about that nut. Nut removed. It was the nut from the holding the top part. There's a second one flying around here. I saw it on the table somewhere. 3 hours. Didn't expect you to be still online. I mean, usually, Paul, I do like, yeah. I mean, I usually start around 19:30, and then I go to 23:30-ish, roughly. So like 4 hours. I think the longest stream I ever did was like over 6, but it was extreme. I really wanted to get the V0 done, so the streams were quite long. Oh, this is I'm very happy with this. The first layer is the foundation of the print. If it's not good, pray for a good, successful print. Yeah, I mean, like, it depends a bit, right? Like, if you... I mean, yes, definitely. But then there's also like a bad, like a visually good first layer and like a technically good first layer. I think, because like for me it's also like what I always look for is like how does it look on the underside. And it might be, for example, this one it sticks well. Like I'm pretty sure this would have worked out. It's just like the underside looks uneven. So if it's like a really like a part where I don't care, I don't care. But if it's a part where like the underside is very prominent, then I also want to have like a nice looking visual layer. For example, like last week I printed something for a friend of mine, which was like the bottom side on the print was later upside down, and it was a circular print. So what I did was actually was like I used the Archimedean quartz infill. It's just like a snake, like it goes out and out and out. And I took like 3 or 4 attempts just to get the first layer perfect. So in the end, I used a texture sheet with the Archimedean quartz infill pattern. Let me just quickly show you that. So I really took my time to make it look nice. So if you go to strength and then the bottom surface pattern, if it's round, I always use Archimedean quartz. And what it does, it gives you like a stupid error again. No, don't save, discard. Primitive, cube. So the strength and then the bottom surface pattern, Archimedean quartz. If you do this, come on. This is how it will look like. So it just gives you circles. And if your shape, like the entire object is round, this looks really nice. So yeah, that's something where like the technical first layer was okay, but then like visually it wasn't nice. For example, you saw layer line, like the extrusion lines, and I didn't want to have that, so I switched that on purpose down in the texture sheet, and it will look really nice. I had a Revo 6 where the heater was bad. The temps jumped around like 20 degrees. Ah, that sucks. You can see on the underside if the nozzle is too close or not. That is also what I'm looking at to check the first layer. Yeah, I mean, it's very easy. It's actually like where the positron is very nice. You know, like the positron prints like upside down. So we look on normal printers, you look on the top surface of the first layer, but on the positron, because it's upside down and has a transparent bed, you look on the bottom side. I feel like this is really nice. Also what I found out while looking at this, there's one called Hilbert curve. It's absolutely useless. It generates this like weird ass pattern. It's really slow. I had it on by accident somehow. It looks really nice. It's a really nice first layer. Like, absolutely useless for anything, but it's a really nice first layer. Let's kill it. Okay. Do you have a schedule or something? Because currently I'm relying on YouTube notifications. I don't have a fixed schedule because I'm not like professional or something. Usually it's always Fridays, except something is on Friday. So if I'm on a birthday party on Friday, then the birthday party takes priority. But usually it's Friday, and usually it's 19:30. That's kind of like the time that worked for me, because like I get home at 5 and then I eat. I have to prepare this. This is my dining table. So every time I stream, I have to set up everything and then take it off again. So Friday 19:30. I do schedule the stream usually on Friday afternoon. So around like 2 to 3 p.m. there should be like a schedule on the channel. Yeah, but it's pretty much it, because usually I also don't know what I do on the weekend on Wednesday. So like, yeah, for me this is a hobby, so it's not super scheduled. Sorry. That resistant error, that is a nice tip. Never thought of that. With the glass bed, yeah, it's really nice. Cool. So looking at this, let me switch this back to autofocus. So this looks really good. Like it's really even. Also down here in the corner and up here in the corner as well. So this looks really, really nice. In the beginning we had issues, right? Then we moved down, we moved the nozzle down a bit in this area, and then we sped up the speed to 150, where we then had like more under extrusion. But I think this looks really good. I'm not sure if Steve approves because he requested the full bed, but I think this looks pretty usable. The only thing that's noticeable, like in the top corner and the bottom corner, you do have, like even here, right, where we were like still too far off the bed, you see like in the corner, it's like over extruded. And then it barely moves into the under extrusion. And this is where the small area flow compensation comes into play. So basically what the small area flow compensation does is, for shorter moves, it reduces the extrusion like on a certain percentage. And you can turn this on. I just didn't like tune it. I just turned it on. Here. I just turned it on once and it didn't give me like great results. So you really have to kind of tune these values a bit. And I didn't do that yet, but that definitely will be required for like the perfect first layer. But besides that, I'm very happy with that. So this just means that the BLTouch was not reliable, which is funny because I did the, you know, like the probe accuracy test, like the one we did in the beginning at some point, where it just like goes up and down like 10 times and gives you like a number. That was quite okay actually. Like there was nothing like out of the ordinary. What I did notice with the BLTouch, I don't find it now, but like I have a screenshot of it. Sometimes like you do the bed mesh and the bed mesh is here, and then you home the printer, you do the bed mesh, and the bed mesh looks the same, but it's like half a millimeter higher or lower. Like not half a millimeter, but like quite a bit. It was more than a layer. So that was like really inconsistent. That was one thing. But yeah, then basically this just shows that like this was just not correctly working in some way, whatever. Like I have meshes here, like I have a lot of meshes on my desktop. And they all look somewhat the same, but they're all a little bit different. And they were done back to back. So if let me just show you two. Let's quickly see how I can open that. So can I? Yeah, look at these two. Let me just close a lot of those tabs. Let me use these two. Let me show you these two. So these two meshes were done back to back. Like just mesh again. And then you can see if I mean, I cannot zoom in, but just like look how it wiggles around. Oh, so I closed it. So these two were just like back to back, and you see how it like wiggles around. And I have like a million meshes, and they're all like that. They're all like ever so slightly different every time you do the mesh. So I think that's just like part of the problem. I just noticed that I was live, not behind. That's why my texts were late. Yeah, that can happen. Do you use the new seam hiding feature in Orca? It never really worked for me. I tried the how it's called, the scarf seams. I have it here. Scarf joints, it's called. So this part here is printed with scarf joints. I didn't tune it. Again, like I feel like you have to spend time to tune it. Yeah, it's too close. Can you actually see it? Wait, is it this one? 1 second. Let me find it. Oh, here. Sorry. Right part, wrong side. This one was printed with scarf joints. Show you? And this is how the scarf joints look for me. And this is just horrible, to be honest. But you can just see like where it like does the joint. And this doesn't look pretty. Like, to be honest, I'd rather have a seam on the edge than this mess. I tried it for like a couple of prints, but like they all looked somewhat like this. And then just like, yeah, just gave up. Not worth the effort. I think what is nice is that they allow you to, what the hell is it called? Like the setting, the percentage where you can like adjust like how much bulge you want on the seam. I think that's nice. I think I enabled that. But yeah, the scarf joints didn't work for me at all. You could that much from the BLTouch. Maybe there was some heat issue, it getting closer and closer to the hotbed. I'm not quite sure if that was the problem, Steve, because I had the inconsistent Z offsets before I cut it. I mean, this is like the BLTouch, right? So, I mean, yes, we cut off the tip. Actually, you can replace the tip. I didn't know that. You can seemingly like somehow pull this out and replace the tip. But yeah, I mean, maybe. But this is also like a very cheap device. It's now like, I have it since forever. That was actually one of the first upgrades to the Ender 3 I ever did. So I think I had it since 2018 or something like that. So it's just a 2019 maybe, 2018? 2018 seems reasonable. So this is just a really old device. I don't know, maybe it's just like something broken. I don't know. It's just like, it's not an expensive device. So I frankly don't care. It's not like they're like €1,000,000. So it's like, I had it for a long time. I used it a lot. I was happy with it. We had our fun. It's okay for now. But by now it's just okay. Cool. Yeah, but I'm not quite sure if we should start something new. I actually wouldn't know what to start. This is for me very important because now I can print my boxes again. So this is what I'm printing at the moment. I want to have like different ones for, at the moment I have a crimping and I have fasteners and I have 2 with electronic parts. And I want to have like 5 more maybe. And those parts need like good first layers because otherwise it's just, you can't do it. I have 3 failed bottom parts. So the bottom part here, I have 3 failed ones, 3. The first one I tried with this bed. And it was like really horrible. Like while laid down the first layer, I was like adjusting up and down the entire time, like quite significantly. And then what happened is like the front corner just started to lift off at some point. So this is kind of unusable because it was warped. Then I was like, okay, maybe it's like the, you know, like maybe it's the bed. I have a polycarbonate glass bed for this machine. So I put the glass bed on, but then for some reason I had, the bed must have shifted. So I had a slight layer shift at some point. Okay, shit, try again. And I had, again, a layer shift, so the glass bed also wasn't quite working. So yeah. I kind of wasted like, I don't know, like 450 grams of filament with this so far. But now I think I feel confident working with this. And this should give me like nice boxes. Let's actually do the peel and look how it, see how it looks below, if I get it off. And it's actually quite well on. I mean, flexing is not really doing it. Ah. Yeah, maybe this is now here to stay. Ah, here we go. That looks really good. It looks really, really even. Like on the side, there's always like with this like build plate, like on the side, you always have a little bit of a different pattern than on the center. And it doesn't even know where to focus because it's so smooth. But this looks really good. And then like here, of course, like this is where it kind of like screws up and there's like some dirt. But this looks really good. Cool. Yeah, then I would wrap it up then. This is weird. I was just looking at the spool and was seeing this. I don't know what happened here. It's completely bent. Just some random section in the middle. Okay. Never mind. I hope this will print fine. Okay, cool. Then, yes, so, next week. Next week. Paul, I will be very certain next week we'll have a stream at Friday, 19:30, European Central Time. We will work on the other machine. Actually, I'm still like, I'm not sure how to call this. So maybe we can do a quick session. So this printer needs a name. I was kind of thinking about calling it chopsticks because of all the rods. So I don't know if somebody has a better name than chopsticks. Now is the time. Otherwise, I think I would call this officially chopsticks starting next week. Yeah, so what we will do, I kind of already start here with the bed. So last week we installed the bottom part. And what I did, like I cut those rods to the wrong length last week. So I fixed that. And then I just put the rods in on the three sides. And then I start prototyping and designing these parts here for the bed. So this already works. You can move it up and down. It's a bit misaligned at the moment, but it works. So next week, I want to finalize the bed basically on both sides then. And then we have to install the bed. And at this point, we need to, I'm still like, what a bit of a question mark for me is like how we home that. My thinking was to actually show it really quick. So there's this like beam here that connects to the bottom part when it's in the bottom position. And my thinking was to add an end stop here in the inside on both sides. So you have two Z end stops. That was one thing. And then the other thing is what I want to do is I want to add a here on the side. I want to add a dock for a probe, for a clicky probe, that we have a clicky probe here as well. Hot Rod. Steve, that's a really good name. Hot Rod. The cube. Also not bad. Hot Rod is cool. That's cool. I think I will do like a like a survey on YouTube, you can do like the it's not survey. Words. I forgot the word. Yeah, you know what I mean. You know the thing, the very commode. So I will put like chopsticks, hot rod, and the cube. And if somebody else has a name, throw it my way, and then I'll make sure to post it this week. Paul, thank you, Paul. Paul, that's the word. Yeah, but then basically we have to do the bed, and if we have the ends, the Z end stops, and we have the bed, this is a printer. Like it can move, like in all directions. So I think what I will also try to do, that we can prepare that. So basically I will have to print these parts for the bed on both sides. And then what I will also prepare is the tool head. It will just be like a normal mini stealth burner. But because I want to have the clicky probe on the side, there's like a modified version with 2 magnets on the side. Like basically just here it has 2 magnets. So that it can like take the clicky probe from the dock. So that I will prepare, and then we can technically make it move. At the moment, these parts here need to be replaced because we switched from the ball bearing to the IGUS bushings here. So these are like different parts, and these are not fitting perfectly. So they're like really loose now. So I don't think we will get like, if we print something next week, it's a big if, I don't think we get great quality out of that. But technically we can at least make it work. And the other thing that came today, also for this machine, like it was such a cute box. So I ordered the new main board. Initially I wanted to use I don't have it here, I have it over there. I wanted to use the SKR Pico, which is a really nice board. But now, after like making it a little bit more premium and everything, I want to have a canvas toolhead board. And the SKR Pico doesn't have canvas support. So in order to get canvas working with the SKR Pico, I would have needed like a separate board. And then you have like the Pi, you have the SKR Pico, and you have the canvas adapter. And it's kind of like a lot of messy cabling then, and it's a really small printer technically. So I want to keep things simple. So I ordered a new board. This was relatively cheap. Like this board is like 25 euros, and it's tiny. It's really tiny. Rodriguez. I put it on the Paul. But yeah, so this board is really tiny. And the nice thing is it has like 4 stepper drivers. So it has the TMC 2209, 1, 2, 3, 4. It has end stops, it has fans and temperature probes and some general GPIO. It has technically BLTouch support. And then it has like 24-volt input, hot end, and heat bed out. And the nice thing is this tiny connector here on the side. This one is canvas. So this has integrated canvas. So to make this work, all we need is this board and this. So these are the complete electronics of this machine, which I find really nice. So it's really compact, really small, so we can find the, what happened to this pin? 4 pin. We find a nice spot for that. Most likely will be on the back of the printer. But yeah, this is like really, really manageable to add. So it's really nice. No, it's not broken. It's improved. But yeah, like this is just like a couple of USB ports on top, and then the only thing I'm like low-key annoyed, like this is kind of like a missed opportunity. I think they should have matched the whole pattern of the Raspberry. Like there's not a lot missing. I get it's really hard to make it this small, but if they would have matched the whole pattern of the Raspberry, come on, this would be so amazing. Like if this could just be like a hat for like full-size Raspberry, This would be amazing. But yeah, never mind. So this is the board. So next time we will do the bed. I assume this will go relatively quickly. So we will also start configuring the software for this bad boy. I wouldn't put like proper cabling yet, because we don't have a spot yet to mount anything, like the PSU and stuff like this. Like there's no mounting spot yet. But we will just use the messy cables we have and make it work. Yes. Okay, cool. So that is the plan for next week. And with that, thank you everyone for tuning in. We're quite a lot of people actually here, like up to 10 I saw at some point, which is pretty nice on a like hot summer evening. So enjoy the rest of your weekend and see you next week. Bye.